Hello, this is Ben and Jim with DC Digital. Today we're demonstrating a RS-485 system. It's a wired system. It creates data in each one of the timers. So we have countdown timers that can be set to 99, 59, and 59 seconds. And each one is independent of the other. However, the data is gathered and for how many of the timers that you have on your system. Right here we have two that we're demonstrating today. We have an A and B timer, so A is going to be addressed A and B is going to be addressed B, but B is going to pull A together with itself and give the feedback of the timer and what's being shown on the timer back to a terminal program that Ben's got set up on the computer. Each one of them has a start-stop switch, which is the palm switch, and also a reset to the set value. And Ben's going to demonstrate how to set the value. Now, another key thing is when Ben sets the value on the down timers, it will retain that memory indefinitely until you change it, but power failure won't affect it. It'll retain the time. Also, I forgot to mention that once they go down to zero, they pass through zero, they will give you a negative sign and start counting back up again to give you all the way up to 99, 59, 9 hours 59, because the negative sign takes the most significant digit. So without further ado, I'm going to have Ben go through and demonstrate how they operate, how do you program them, and what you should be seeing on your computer screen once the data starts flowing to it.
Okay, thank you, Jim. Each timer has an RS-485 input that is acting as a slave and an output that is acting as a master. So each one sends data down its master line to the next one, receiving on its secondary line, and then that forwards that data to the following timer until the last timer communicates back to the computer. The computer is set up with two RS-485 networks, a send and a receive, a transmit and a receive. So to set either timer, it has a channel designation. This one is channel A and this one is channel B. And so to set it, I'll type in the letter A followed by a lowercase s to indicate that I want to set timer A's time.
So it's going to be an uppercase A or whatever the designation of it.
Capital A and a lowercase s. And then the hours, minutes, and seconds that I want to set it to. This is a countdown timer. So we're going to set the start value. For the purpose of this video, I'll just set it to something low. So 0 hours, 0 minutes, and 5 seconds. And I'll hit enter, and then you'll see 5 seconds pop up on the screen. And we'll go ahead and start that. So you can see the counting down in the negative. I'm going to set B. So B will be capital B, lowercase s, 0, 0, 1, 0, that's 1 minute. Sorry, that's 10 minutes, backspace. 0, 1, that's 1 minute. And 0 seconds, we'll put that on the screen, and that's what 1 minute looks like. You can see A is now counting into the negative. Jim, can you hit the start button over there? So now B is counting down its minute, and then it'll go into the negative. If I send A start value, A lowercase s, 1 hour, 15 minutes and 0 seconds. It receives that start value, but it doesn't change anything until we stop and reset A. And then when we start A again, that's when it will update. However, if it is stopped in its reset position, we can type in AS 0, 0, 0, 0, 1, 0. So now it's set to 10 seconds.
But you always have to put in 6 digits.
Yes, you always have to put in 6 digits.
So you have to put in 2 for the hours, 2 for the minutes, 2 for the seconds. Regardless if you just want 5 seconds.
It'll start by showing minutes and seconds. It'll go up past that to hours and minutes, up to showing only 10 hours, right? 9 hours and 59 minutes. But here on the data output, as all of this is being sent back to the computer to give the management direct and remote feedback of where the processes are in the factory. They can see here all the way up to 99 hours and 59 minutes and 59 seconds of downtime. So even though it may stop at 9 hours here, they'll be able to continue to track downtime remotely in the data that comes back out of the timers.
Now this is just a terminal program that you can get for free?
Yes.
Right?
Yeah, this is a terminal program. There's a number of them.
And it's set up for 9600 8N1, right?
Yes.
So we're transmitted 9600.
9600 8N1.
We're
We're coming out of here with a USB to serial adapter, and then going into this box, which is a 232 to 485 dual isolated box. And so then from there we have a normal 485 network.
So the system is, the box transmits whatever code that you program the timer for. So you could be programming timer X.
Yes.
And it'll go through, it has to go through all of them to get to X, unless X is the first one in line.
Correct.
So, and then you have to have a return transmit back to the 485 for it to come back and give you the feedback from whichever last one you had on your line.
Yes.
To see all of them.
Correct. They do not have to go in any order. We're going in order of A and then B and then computer, but it could be A computer, it could be A, B, C, D. You could skip a letter and start with X, Y, and Z, add those to the line. In any order, they will report back, but they do need to go from the computer to the input, from the output to the input, output to input,
transmit
back
to receive. Yeah.
Yes.
And then the last one has to come back to give you the accumulated everyone that's been connected.
And it updates once per second on the data coming back. So the data coming back is each timer once per second.
It's once per second, gives you all of the timers. So again, this is Ben and Jim, and we are discussing a DC-40T-DN, and we're going to give it a RS-485 part number on top of that. Thanks for watching.